Hey, welcome. Today, we're going to peek under the hood of the software we all use every day. We're going to uncover a surprisingly simple secret that keeps it all from falling apart. It's a testing technique called condition coverage. And trust me, it makes a way bigger difference than you might think. You know the feeling, right? You're right in the middle of something important, and bam, the app just crashes. Or a button does absolutely nothing. So frustrating. Well, it turns out that a lot of these failures start as these tiny, almost invisible flaws deep inside the code. But what if? What if there was a way to hunt down these exact flaws before they ever see the light of day? So, to stop those annoying bugs, we can't just look at what a program does on the outside. Nope, we have to go deeper and understand how it thinks. It's time to get our hands dirty and look at the code itself. And that brings us to something called white box testing. So instead of just poking at an app from the user side, this method lets developers see all the internal wiring, the actual logic, the structure of the code. Think of it this way. It's the difference between just testing if a light switch works and having the building's entire electrical blueprint in your hands. Okay, so you've got the blueprints. That's great. But how do you know you've actually checked every single wire in every single room? That's where code coverage comes in. It's a metric that basically asks, hey, what percentage of our code did our tests actually run through? Now, a high number sounds fantastic, but it doesn't really tell you the whole story.
To get the real story, we have to zoom in, way in, past the lines of code and into the tiny, split-second decisions the software is making. And this, right here, is where we find the real key to stability: condition coverage.
So what exactly is condition coverage? Well, it's not just about making sure a line of code gets run. It's about testing every single tiny logical question inside that code. It forces us to prove that every little piece of a decision has been tested as both true and false. Now, here's where people sometimes get mixed up. There's a simpler method called decision coverage, which just checks if the code took the if path or the else path. But condition coverage, it's so much more detailed. It makes you look inside that if statement and test every single little part, like asking, is x greater than 5? And separately asking, is y equal to 0? And yep, this is something you can actually measure with a pretty simple formula. You just take the number of condition outcomes you've tested, divide it by the total number of conditions that exist, and voila, you've got your percentage. The goal, of course, is to get that number as close to 100% as you possibly can. All right, enough with the theory. Let's see how this thing actually works in the real world. A quick example is going to show you just how powerful this really is. The whole process follows a few clear steps. First, you hunt down all the decision points in the code. You know, the if this, then that stuff. Then, you break those decisions down into all their individual little questions. After that, it's all about designing and running the tests. And finally, calculating that super important coverage percentage. So, let's say we're testing this little piece of code. Pretty simple, right? It has two main decision points. The first one uses an or, and the second one uses an and. Now, if we break that code down, we find 4 individual conditions that need testing. Our job is simple. We need to create tests that force each one of these to be true at least once and false at least once. And check this out. This is the really cool part. It turns out we can cover all our bases with just 2 test cases. See? In the first test, x is true, and in the second, it's false. We've done the same thing for y, z, and w. With just 2 really smart tests, we've hit every single possible outcome for every single condition. That, my friends, is 100% condition coverage. So you might be wondering, is all this detailed, nitpicky work really worth it? Oh yeah, absolutely. The payoff is software that just works, software that doesn't let you down. It's all about reliability. See, by focusing on this incredible level of detail, you can find those subtle, hidden little logic bugs that other tests would completely miss. It helps you prove that the code behaves exactly the way it's supposed to, which means more stability, fewer crashes, and, at the end of the day, a much, much better product for everyone. Now, condition coverage is incredibly powerful, for sure. But for the most critical software out there, I'm talking life or death stuff, there's actually a way to go even further. We can kick this up a notch. This is called Modified Condition/Decision Coverage, or just MCDC. It takes everything we just talked about and adds one crucial, rule. You have to prove that each individual condition all by itself can be the one single thing that changes the final result. Think about what that means. You're proving that just flipping one switch while all the other switches stay exactly the same can change everything. This level of rigor is precisely why MCDC is the gold standard for software where failure is simply not an option. We're talking about airplanes, medical devices, you name it. If you need a simple way to remember the main idea, just think C-cubed. Condition, coverage, checks, conditions. It's all about drilling down into those individual little pieces of logic. Which kind of leaves us with a final thought, doesn't it? In a world that is completely built on software, every single if, and or is a tiny choice the program makes. So if every single one of those choices isn't properly tested, can we ever really say the software is truly finished? Thanks for joining me.